So let's start with our second problem over here. Okay, Ligaya wanted to fit a building model at one of the corners of a small replica. The two lines intersecting with the small replica are tangents to it. Okay, so these are the two lines that are tangent to this circle that we have here, this base circle for the replica of the mall. Okay, so there is a point on the shorter arc of the circle between the 2 points of tangency that is 6.5 inches away from one tangent and 6 feet inches away from the other tangent. So we need to find the radius of the circle mall of the replica. For this one, we need to find the radius. So guys, to make our problem more simplified, let's draw it over here. Okay, we're gonna draw the problem here, and then we're gonna draw a circle. Okay, so it's not a perfect circle. There you go. Okay, so this is the circle that we created, and we know from this problem, okay, we know from this problem that this side measurement over here, that should be 6 inches, and this side measurement over here, so that should be 6.5 inches. And since this is a circle, guys, since we have here a circle, it should have a radius. Okay, so this is the radius of our circle. Okay, and this could also be a radius for our circle. Okay, so this is also the radius. Okay, so in a circle, always remember this theorem. The radii, all of the radii in a circle are just the same. They're just equal to each other. And this could also be a radius. Okay, so this could also be a radius for this problem. Okay, now try to look closely, guys. This line here, the radius, is going to be parallel to this line that we're going to be creating here. Okay, so therefore, what's the value of this line segment that we have here? Okay, so the second line segment, since this is 6 inches and this is r, okay, so this is r, this line over here, it could be represented by r minus 6. Okay, and then we have here another line segment. Okay, so we have here another line segment, so that's also r, but take note that this line segment is equal to 6.5 and this is r. So therefore, this third line segment over here, so that's going to be r minus 6.5 or r minus 13 over 2. Okay, yeah? And therefore, if we're going to zoom in, if we're going to try to zoom in into the triangle we've created, that's going to be a right triangle, okay, for this one. So the value of this hypotenuse is equal to r. The value of the legs are r minus 6 and r minus 6.5, or if we're going to use the fraction of it, r minus 13 over 2. Okay, and therefore using the Pythagorean theorem, okay, a squared plus b squared is equal to c squared, we can solve for the value of r, or the radius of the circle, because this is what we want to find essentially for this problem. Okay, so therefore this is gonna give us, okay, so any of the two, okay, so any of the two of here can be a or b. Okay, let's say this is going to be a and this is gonna be b. So this is gonna be r minus 6. Okay, let's write that neatly. Okay, just a minute. Okay, let's write that neatly though. Okay, so that's gonna be, okay, let's use the pen. Okay, so for this one, so this should give us, the equation essentially should be, okay, it follows that the equation should be r minus 6, okay, squared plus r minus 13 squared should be equal to r squared, or the radius of our circle, of the base of the mall replica that we have here. So therefore, what's r minus 6 squared? That's just r squared minus 12r plus 36. Okay, and what's r minus 13 over 2 squared, guys? So that should give us, again, r squared. Okay, and what's negative 13 over 2 times 2? So that should give us, okay, that should just give us, okay, so 13 over 2, yeah, 13 over 2 plus 13 over 2. So that should give us, that should just give us 13. Okay, so for this one, this is going to give us minus 13r. Okay, and what's 13 over 2 squared? Okay, so that should give us 169 all over 4, right? 169 all over 4 is equal to r squared. Okay, and then we're just gonna simplify like and unlike terms. So these r squares will cancel out, and this should give us r squared. So what's negative 12r minus 13r? That should give you negative 25r. And what's 36 plus 169 all over 4? So 26 plus 169 all over 4. So that should give us 200. I'm sorry. So that's 36. 36 plus 169 all over 4. So that should give us positive 313 all over 4. It's going to be all equal to 0. So therefore, this is our quadratic equation. And using the quadratic formula, we can solve for the value of r if we use our numerical coefficients for this problem. Okay, using the quadratic formula, we have here x, or rather, we could write, okay, for this one, let's try to use r. Okay, so for this one, let's transfer this formula over here. Okay, so that we have a lot more space. So that's r squared minus 25r plus 313 all over 4 is equal to 0. And we can say that a is equal to 1, b is equal to negative 25, and c is equal to 313 all over 4. Therefore, r is going to be equal to negative b plus or minus the square root of b squared minus 4ac all over 2a. Yeah, for this one, guys. So this should give us positive 25 plus or minus the square root of b squared, which is negative 25 squared, minus 4 times 1 times 313 all over 4 all over 2 times 1. So this should give us 25 plus or minus 25 squared is just 625. Okay, so that should give us 625 times, okay, minus 4 times 1 times 314 over 4. So the 4 cancels out. This should give us 313 all over 2. And what's 625 minus 13, guys? 313. So that should give you 312. So this is going to give us 25 plus or minus the square root of 312 all over 2. Or if you're going to try to simplify that, the value of r should be equal to 25 plus or minus, what's the square root of 312, guys? So that's equal to 2 square root of 78 all over 2. Okay, so we can only take either one of the values. Is it 25 plus 2 square root of 78 all over 2? Or 25 minus 2 square root of 78 all over 2? Let's try to evaluate both of them. Okay, we're going to get, okay, so that should be 25 plus 2 square root of 78 divided by 2. We're going to get the decimal value is equal to r sub 1 is equal to 21.33, and r sub 2 will give us, so that should give us 25 minus 2 square root of 78 divided by 2. So that should give us essentially 3.67. Okay, so we can see clearly now which of these two values should we take. Okay, for this one, it should be the one with the addition symbol. R is equal to 25 plus 2 square root of 78 all over 2. So why can't this be the value of R? Because remember, if we're going to try to if we're going to try to subtract 3.67 from 6, it's going to give us a negative value. Okay, and these are real-life measurements. So therefore, the value of the radius for this problem is going to be 25 plus 2 square root of 78 all over 2 inches, or just simply 21.33 inches. Okay, for this problem. And you can even further simplify this. This could be 25 all over 2 plus square root of 78 inches. Okay. And that's how we solved it for this problem, guys, for our second tangent problem.